Hey, hello everyone. So I hope you are doing good and you have watched some previous videos. If you haven't watched, then link will be in the description. Go to the playlist and watch that serially. Okay, today we are going to talk about the normal equation. Okay, and we'll be trying to find the like minimize the loss function. All these things we'll be seeing. Um, First, just see that consistency is what transforms average into excellence. Yes, so average people doing consistently work on something and they actually become excellent consistently. Okay, yeah. So let's go and we also work. And I just want you to watch this video till the end. That's why I put this code. And let's go. Here, the normal equation. Okay. So we'll be seeing what is the normal equation. This is the thing, guys. Okay, this is the normal equation you can see here. Okay, this is the thing. Okay, to find the value of theta that minimize the MSE, exists a closed form solution. Okay, so there is a closed form solution. We'll be seeing that. Not to worry. So to make this things more simple, I just quickly put into the chat GPT and make this more simple to understand. So let's understand this. Okay, so there is a formula to find the optimal parameters because we what we are trying to do, we were trying to do optimal parameters that can actually minimize the loss. So there is a one formula that is this is the formula. Okay, guys, and X is the matrix of the input feature, Y is the vector of target values. Okay, so it's the vector of target values and theta is the vector of parameters like weights. Okay, so we'll be just doing it practically, guys. We have written the code. We have just imported the NumPy and the link of this Google Colab notebook. You'll be seeing in the description. So not to worry. Just go there, use that, and do some experiments with yourself. Okay. So let's run this. So we have just imported the NumPy, and what we are going to do, we are going to make a random data set. Okay, so let's make it, and you'll be seeing this data. I have just plotted it. Okay, so you can see here. This is the data. You can, if you are familiar with it, then you can see here that there will be a linear regression line. To make this simple, we are taking the linear regression for now, and from now, like we can just add a bias term. Then just run it because you can see that this is the formula of the normal. Okay, so this is the same formula that is working here, and then let's run this and run this. Okay, so it is actually predicting. Okay, you can see here we are predicting this. So you can see a linear regression line is there. Okay, I don't know that how much this is perfect, but will be so this was a quick video. Okay, that how the normal equation works. But this is the substitute, not substitute. This was before the gradient descent. Okay, gradient descent is more iterative process. So we'll be seeing on this data set itself. Okay, let's see. Okay, let's see. Just ask ChatGPT. I'm just going to ask ChatGPT. Put the gradient descent on it and then give me the predictions and make the graph. Okay. So it will be giving us a quick thing. In detail, I'll be doing some coding and showing you that okay, this is the thing going to be okay. So okay, okay, it is going to do this thing. Okay. So making thing more quicker, we are using ChatGPT. You can see here. Okay. So they have found exactly the same. Okay, they have found exactly the same. But we have a question like why? What is the difference between a normal equation over the gradient descent? Okay, so why use the normal equation provides a direct solution without iteration, making it faster for a small data set. Just remember this thing, guys. Like normal equation is working in a small data set. Okay, yeah. On the big data set, actually the gradient descent will be working, and in next few videos we'll be seeing the gradient descent because there is a huge part of the gradient descent, and this was just a demonstration of what's going on, and we'll be also seeing the computational complexity, that how much complex this method is, like normal method and the gradient descent method. So how much complex both are, and what is the time complexity, not to worry about what is the time complexity, is our computational complexity. Okay, so we'll be seeing that, not to worry, and in the next video we'll be taking the computational complexity and then gradient descent. So yeah, I hope you understand this thing. This was a normal equation. You can see here, this was the normal equation we are using, and we have just used some uh, a data set, a random data set we have taken, and then we are going to plot it. Okay, so it's something like that, and we have also used the gradient descent to find, and it was found exactly the same. And why this was same? Because this is a smaller data set. Okay, so that's, I hope that's too much clear for you. And thank you guys for watching this video and being consistent with me. In the next video, we'll be seeing many more things. Thank you so much, guys.